I want to go over some of the more important things from the last unit and some of the mistakes I saw on the lab that were relatively common. So I want to just try to clear some things up. Everything I'm going to talk about here in this video is crucially important to 1047. Knowing what a mole is, knowing how to convert moles to grams, things like that are going to be first steps of things you'll be doing next semester. And so it is very important that you're clear on this. And so if this video doesn't clear up any of your questions or concerns, or that you're still having trouble with the math or the ideas, please get a hold of me ASAP before this course ends, because again, this is going to be stuff you're going to very much need to know moving forward. Some of the most important stuff in all of intro chemistry really is the conversion of moles to mass and mass to moles. Knowing how many molecules you have, like that, I know that's asked, that's actually less important. The moles cover that. In the same way, is it important to know you have 24 donuts when you can just say 2 dozen? 2 dozen means 24. And so the moles are how we do the counting. So that brings me to moles to start off with. The symbol N in this formula that you see is what moles is. Moles is just a number. It is the answer to the question, how many do you have? I have 1 mole. I have 10 moles. I have 2.6 moles. It is a how many question. It has nothing to do with mass. A lot of people told me it had something to do with mass in the question, in the conclusion on the lab activity, and so I want to make sure that's clear. A mole is just a counting number, the same way we use a dozen. Because atoms and molecules are very small, we have lots of them, and so we say a mole is a collection of 6.02 times 10 to the 23. But again, both of those things, how many do you have, can be answered by the number of moles or by the actual number, the same way 2 dozen is the same as 24. And so again, moles, doesn't matter what we're talking about, it has nothing to do with mass, it only has to do with counting. Now, it's related to mass, mass being little m in the equation in grams here. This is the exact same thing as you think of when you buy something at a store and you look on the box and it says, 500 grams, whatever. You think of it as weight. It's a slightly different concept, but sure, we can say weight if we want for this purpose. But the mass of something is really what you put something on a scale, you get its mass. And so that is the same as your probably everyday experience with that sort of thing. Molar mass, on the other hand, is what 1 mole would weigh, or what is the mass? How many grams is 1 mole of anything? So if you take, for instance, salt, NaCl. A lot of you use that as one of your chemicals, and you use the periodic table. This part was pretty well done to find big M. Molar mass is you take the 22.99 for the sodium, the 37 or 35, I can't remember now, whatever it is for chlorine, and you get a molar mass of 58.44 grams per mole. What that means is if you were to take individual salt NaCl particles, molecules, compound, whatever you want to call it, and put them one at a time on a scale, by the time you reached 6.02 times 10 to the 23 of them, or 1 mole, you would have a mass of 58.44 reading on that scale. And so molar mass, we read that off the periodic table. That is something you don't normally calculate, because you would use the periodic table to figure out the number of moles or the mass in this equation. Big M is almost always, you just use the periodic table to find it. But what it's telling you is when you have this number, Avogadro's number, 6.02 times 10 to the 23, 1 mole of whatever it is you're looking at off the periodic table, this is what you would see on a scale if you'd put that on a scale. And so this is what connects moles to mass. And that is, again, an important concept to keep in mind. Lastly, the number of particles is just your number of moles, the same way, how many donuts do I have? If I have 2 dozen, you take your number of dozens, there's 2 of them, times what a dozen is, 12, and so you would get 24. So in this case, you take your number of moles and then times it by Avogadro's number, 6.02 times 10 to the 23. This is something you will do in this unit, but it's not something chemists do a whole lot of. We usually just stop at moles and say, yeah, we know how many we have. We have, 3.2 moles of it. So those are the ideas. You must be very clear on those. The other thing you need to be very clear on is how to use this formula and how to rearrange it. Again, you'll mostly always be asked for moles. Find moles from a mass, little m, or find little m mass from a number of moles, because molar mass is given on the periodic table. So you should know how to rearrange this. If you were asked for the mass in grams instead of the moles, you would rearrange that to be N times big M, or what does 1 mole weigh times the number of moles you have. If 1 mole weighs, say, 100 grams, and you have 2 moles, well, then the whole thing weighs 2 times 100, 100 grams. That's essentially what that formula does. And this is one I usually don't tell students to rely on, but this little trick works. If you can't remember the formula, or you want to know for sure how to rearrange it, if you want to know the number of moles, this triangle will tell you it's little m over big M. And if you wanted to know the mass here, well, it would tell you that it's little n times big M here, as we see in red up here. So that's the two versions that you're going to use this formula. And again, these are going to be expected that you know how to do this without thinking too hard about it in 1047. So let's do a quick example here. 1047, you're going to be looking at reactions. You're going to be doing stoichiometry, which usually means you will start with so many. They'll say, oh yeah, you weighed on a scale this many grams of some chemical. Now you're going to react them together and you're going to produce some products. How much do they weigh? How much are you going to get out is kind of the question. And so the first thing you got to know then is, if you're starting with a certain reactant here, its mass, and in this case, it's 50 grams. The first step of that process, which I'm not going to tell you the whole thing, you can wait till 1047 to know the rest of the steps, but first step of this thing you'll be doing in 1047 stoichiometry is finding the moles. It's the first step of that. So you'll want to know the number of moles of this chemical, H2SO4. Again, this is where your naming skills come in. If I didn't tell you H2SO4 and I only told you sulfuric acid, would you know that it's H2SO4? That's super important, because now you know that to find the molar mass, you need to know all of the atoms in the formula itself. So this time it's given. That's great. Sometimes it will be, sometimes it won't. So 2 times 101, there's our hydrogen, grams per mole, sorry, plus 1 sulfur, which was 32 point, where am I, 06 grams per mole, plus 4 oxygens, which was 16 grams per mole. Again, this was okay. I thought this wasn't a big issue on the lab, so just make sure you can do this though, reading these off the periodic table, and we get a total of 98.08 grams per mole. So what that's telling us is, if we put 6.02 times 10 to the 23 H2SO4s on a scale, it would read 98.08 grams. So now we want to use our formula to figure out the number of moles, which is the little m over big M formula. And note here, before you do any math, you should just think about this, that you have 50 grams of this chemical and you want to know how many moles that is. Well, if you understand that molar mass tells you how much a mole weighs, and you've less than that, you only have 50 grams, not 98.08 grams, then we should expect a number less than 1 for our number of moles. And if you look really close here, you can see that 50 is almost a little more than half of 98, right? 98 is almost 100. So we're expecting around half a mole here is what this would equal. And again, we're answering the question, how many of these H2SO4s do we have? I do that math, and I get roughly 0.51 moles. So a little over half a mole is how much 50 grams of H2SO4 is. Again, the mole number itself, 0.51 moles of anything, is the same number of them. It's the molar mass that then relates to the 50 grams here. Well, how much is that in terms of moles? It's the 98.08 grams per mole, which is unique to H2SO4, which connects the mass and the moles together. So that'll be your first step on some of the things you'll be doing next semester. So make sure you can do that and make sure you're clear on all that. The other thing you're going to use this formula for is when you do this stoichiometry stuff, you'll look at your products and, well, how much did we make? Well, it'll be easy. Well, not easy, but there'll be a way to figure out the number of moles that you make. And so in this question, I'm saying this certain reaction, this other reaction maybe, produces, we don't know what these reactions are. I'm just getting, showing you some steps you'll need to know. This produces 3.7 moles of CaNO3, which is calcium nitrate. So again, remember that you need to know how to get the actual atoms that go into a compound from its name. So the naming is important. And the other step you'll need to know how to do, which we're not covering in this video, is balancing equations. So those three things together, using this formula the way we're doing for these two examples, balancing equations, and then writing the chemical formulas from the names. Those are going to be things that if you do want to do some review before 1047, those are the things that I would make sure I was really clear on. So in this question, we want to know, okay, well, no one really talks about that in real life, right? You might say a chemist would. 3.7 moles, great. I know how many I have, but what does that weigh? What's the mass of that? If I put that on a scale, what's that going to weigh? That's really the question. And that's how we normally would talk. We would say, oh, we have, 300 grams of that, this or that kind of thing. So that's what we want to know in this case. Once again, we need to figure out the molar mass. In this case, there is 1 calcium. So 1 times 40.08 grams per mole. Plus, remember now, this isn't 1 nitrogen, it's 2 nitrogens, plus not 3 oxygens, but 6 oxygens. And when we add all that up, we get 164.1 grams per mole. So this chemical, we would know that if we had 6.02 times 10 to the 23 of them, that it would have a mass of 164 grams, unlike the sulfuric acid, which was a different number because it's a completely different chemical. Now, we don't have 1 mole of this. If we had 1 mole, the question would be answered. It's done. We know it's 164.1 grams for 1 mole. We have 3.7 of them. And so think about this logically. If you have 3.7 times more than 1, well, then this mass is going to be 3.7 times more than the mass of 1 mole. And sure enough, that is what the formula tells us to do. It tells us to take our mass of one mole and times it by the number of moles we have. And so 3.7 moles times 164.1 grams per mole, and we get an answer of 607.2 grams of calcium nitrate. And that's, again, how we normally talk. It's like, oh, how much calcium nitrate did you make? You'd probably say 607.2 grams. You'd probably know that it's 3.7 because you would have had to do that as part of the calculation. But again, that's not the way we really talk. We use moles to get these masses back out in the end. So if any of this is still confusing you, or if you had trouble with the worksheet still, I promise you this isn't going away. So please get in touch as soon as possible with me. Review this stuff and make sure you're as clear as you can be before you move on, because it will get you on in the next semester. So please get in touch with me if you need me, and good luck.